Hello everyone, and then welcome to another tutorial video. So in this video we'll be treating the introduction to differentiation. Okay, so we'll be treating the power rule, the product rule, the chain rule, and the quotient rule. Okay, so in case you are new to this channel and you want to see more of these videos, I would urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on newly uploaded videos. Like the video, share the video, and in case you have any questions, just leave them in the comment section. I'll reply to them as soon as possible. Okay, so let's dive right into this video. Okay, so we have the power rule. So we'll be starting from the power rule. So let's look at the power rule. The power rule is, I would say, quite simple. Okay, so in case you don't know, so differentiation is all about addition. Okay, so once you know how to add, you are good to go. You are always trying to add, and then vice versa is what? The vice versa is integration. Integration is all about subtraction. Okay, so let's see how we do that. So power rule is quite simple. Let's say you have x exponent 5. Okay, it's x exponent 5. Okay, so we want to differentiate this. So per this formula, you can notice that this is the exact representation of x exponent 5. So n is 5 and then x is x. So once you want to differentiate, you just bring the exponent as a coefficient of the x, and then you subtract 1 from the exponent. Okay, again, bring the coefficient bring the numerator of the x of the x as a coefficient. Okay, so you bring it in front of the x. After that, you subtract 1 from the numerator. Okay, so you have 5 x exponent 4. Okay, see how simple this is. And let's take another example. The same principle implies you just bring the 4 in front of the x, and then you subtract 1 from the 4. So bringing the 4 in front of the x, we have 4. Then we have 2x, and then you subtract 1 from the 4, we have 3. And then when you do the simple multiplication, you end up with 8x exponent 3. Okay, so you just multiply 4 throughout. Now, in case you come across x, okay, in case you come across x, you use the same principle. Okay, so you know that x is x to the power 1. Okay, we don't write the 1, and then anytime you see any number raised to the power 0, it's equal to 1. Okay, anything raised to the power 0. So let's say you have 100 raised to the power 0, it's 1. Okay, x raised to the power 0, it's 1. So from here you can notice that 1 is the numerator, so you bring 1 in front of the x. That will give us x. We don't have something like 1x. Okay, but when you subtract 1 from the 1, which is already the exponent, we have 0. Okay, so this will give us 1. Okay, this is what you need to keep in mind. And then when you differentiate any constant, you get 0. Okay, so when you differentiate 5, you end up with 0. When you differentiate 100, you end up with 0. That's what you need to keep in mind. Okay, so we're just finding the differentials of these expressions. Okay, we just find the differentials. Now this is all about the power rule. Okay, so let's move on to the product rule. Okay, now let's look at the product rule. Okay, so for the product rule, just like we know already, product is just multiplying two expressions. So when you want to take the product of x and y, is just xy. Okay, so the same principle applies over here. But for differentiation, okay, so for product rule, okay, so this is how we represent product rule. So this is the differential, you have u and v. So u will represent a specific expression, v will be another expression. Now, so for product rule, you keep one. That's the rule. Okay, you keep one expression, you differentiate the other, and then after that you add that to the other expression, and then you differentiate the other. So for product rule, this is how it works. You keep u, okay, and then you differentiate v with respect to x, and then after that you add it to when you keep v, and then you differentiate u with respect to x. Okay, so let's take an example. Okay, so this is a simple example. Okay, so this is product rule. This is where we'll be implementing product rule. Now for product rule, as I already stated, you keep one variable, differentiate the other. After that, you add it to the other variable and then you differentiate the other. Okay, so let's say that these are u, and these are v. Okay, so you just implement this principle. Okay, so you keep u, you differentiate v with respect to x, and then you add it to what? Keeping v and then differentiating u with respect to x. So let's do that. So let's keep u. So u is what? X squared plus 1. Okay, and then let's differentiate what? V with respect to x, this expression. So we have what? 4x cubed minus 2. Okay, add it, keeping v. Okay, so now let's keep v, which is what? X exponent 4 minus 2x, and then you differentiate what? U with respect to what? X. So we have what? 2x. Okay, so because we already know that when you differentiate a constant from the power rule, you end up at what? 0. And then from here we have what? 2x from the power rule. So from here you can just do your simple expansion. Okay, you can just do a simple expansion. So when you multiply x squared by 4x cubed, you end up with what? 4x exponent 5. And then when you multiply x squared by minus 2, you end up with what? Minus 2x squared. You just proceed from there, and then from here we have what? 4x cubed, and then minus 2, and then you continue from here. So we have what? Plus 2x by what? X exponent 4. That's what? 2x 5, and then you have what? Minus what? 4x squared. So when you simplify this, okay, this is what you will get when you simplify this expression. Okay, quite simple, very, very simple. Let's take another example so that you get to understand it more. So let's say this is example 2. Okay, so the same principle, these are u, and then what? These are v. So let me tell you something. There's no need to use this principle. There's no need to use this principle. Once you solve more questions, it will just come at you. Okay, so all you have to do is just, once you see it, you differentiate, keep one, and then you differentiate the other, and then keep the other. Okay, so keep this, differentiate this. After that, you add it to what? Keeping this and differentiating this. Okay, so keep u, differentiate v with respect to x, and then after that, keep v. Okay, and then differentiate u with respect to what? X. Okay, so let's do that. Differentiate v. Okay, so we have what? 2x. Okay, so this goes to 0, plus you keep v, differentiate what? U. You see how simple this is? Very, very simple. After that, you just do your simple expansion. Okay, let's do the simple expansion. So we have what? 4x cubed plus what? 12x. Okay, it's quite simple. After that, you can just further simplify this. Okay, this is very, very simple. Notice that this is very, very simple. Now let's proceed to what? The chain rule. Okay, so this is how the chain rule implies. Okay, I will just explain the expression. After that, I will show you a simple approach to what? Solving it. Now, to differentiate a chain rule, so the chain rule is something like you have x plus y, okay, and then we have an n, okay, x plus y and then an n. So for you differentiate what? Y with respect to u, and then you multiply that by what? U with respect to x. So this is the expression. So let's say we have a specific expression as u, and then you have what? X. Okay, but there's no need to do that. Let me teach you the simple approach. So let's take an example. Okay, so this is an example. So in order to differentiate this is what you need to know. This is something like a combination of the power rule and what? The chain rule. Okay, this is all you have to do. Just bring this exponent, okay, to the front of the what? The entire expression. Okay, after that you multiply that by what? The differential of what is inside the bracket. Okay, so this is what I'm trying to say. So bring this. So use the what? Power rule. Okay, 3 and then what? X squared plus 2. So when you subtract 1 from here, you have what? 2. After that, you just multiply this by what? The differential, which is in the bracket, which is what? 2x. Okay, this is how simple this is. Okay, so you just treat this expression as what? maybe x, okay, and then after that you just differentiate. So we have this expression x squared plus 2 whole exponent 3, and then you just bring the 3 outside to make it the coefficient. After that you just differentiate, and then after doing that you just multiply the differential of what is inside the bracket, okay, just like here. So you bring this outside, from here 3 in front of this expression. So this, you are just using what, this principle, maybe this is u exponent 3, okay. So when you differentiate u, you have what, 3u squared. So the whole of the x squared plus 2 is just the u, okay. After that you differentiate what the u is, okay. So you try differentiating what is inside the u, hence they come out, they try to, hence this formula. So let's take another example so that you get to understand it better. Okay, so the same principle. So you just bring this one, okay, just like the power rule. So this is what you are looking at, okay. So let's say this is what u exponent 50, okay. So you differentiate this u respect to x, okay, differentiate that, and then you get what, 50, and then x squared minus 1 exponent what, 49. Then you multiply that by what, the differential of what is in the bracket, which is what, 2x, okay. This is quite simple, very simple. So from here you could further go on to what, just multiply. You get what, 6x, and then you keep what's in the bracket, okay. You can go further to, you know, simplify. So the same thing applies here. You can just further, so you have 100x, that's multiplying 50 by 2x9, okay. Very simple. Let's take the last example, okay. Let's take the last example. Okay, so let's try. Okay, so differentiating the same principle, you just bring the numerator as the coefficient, bring it here. So when you subtract 1 from 2, you end up with 1, and then after that you multiply that by what is inside what, the bracket. Okay, so we have what, 5 minus what, 8x, okay. Final concept, which is the quotient rule, okay. The quotient rule. I'm trying to make this video as simple as possible so that you get to understand. So now let's see how this also is being represented, okay. Okay, so when you stay till the end of the video, I will give you a simple technique, okay, a simple trick as to how to easily solve quotient rule, okay. So now let's see. So for quotient rule is just like something like x plus y, okay, divided by x plus maybe y or whatever, okay. So it could be a combination of what, a quotient, and then you have what, a chain rule added, so something like x plus y exponent maybe n or something, okay. So all you have to know is that quotient rule can be simply solved as what, using another rule, okay. So I will teach you that once you stay to the end of the video. So let's see an example. Let's take an example. So we have what, let's say we have y is equal to x plus 1. Okay, so this is our question, okay. So we have what, x plus 1 over what, x minus 1. So this is our expression. So this is what, in the quotient form. So you have to differentiate this in the quotient form. Note that, keep this in mind, note that the denominator is always v, okay. The denominator is always the v, and then what, the numerator is the u. Keep this in mind. The denominator is the v, the numerator is the u. Now from here it's just like the product rule. You keep one, differentiate one, you add, and then you keep one, and then you differentiate the other. But this is what, quotient rule, so you have to use what, subtraction. So you keep one, you differentiate the other, and then you subtract that from what, so that you divide the whole expression by what, v squared, okay. So you know that this is v and this is u. So let's use the principle. So we have what, keeping v, differentiating du dx. So this is what, u. So you just keep a v and differentiate this. After that you subtract that from what, keeping u, and then differentiating v, okay, just like here. So let's keep v first. So we have what, x minus 1 and then let's differentiate u. Okay, subtract that from what? Keeping u, which is x plus 1, differentiating what? V, which is also 1. Okay, after that you divide the whole of that with what? V squared. So these are v, so we have what? X minus 1 all squared. Okay, this is what it implies. Okay, so keep v over here, differentiate u, subtract that from what? Keeping u, and then differentiating what? V. After that you divide the whole expression by what? The v squared. Again, the denominator is always the v. Okay, the denominator is always the v. So from here you can just further expand. So you have what? X minus 1. Okay, so note that the whole of this is in what? Brackets, because of this negative sign. Then you have what? Minus what? X. This will give us what? Positive what? 1. Okay, divide that by what? X minus 1. I'm trying to do this systematically so that you get to understand. So from here we have what? X, okay, minus 1 minus x minus 1. Okay, and then we have what? X minus 1 all squared. So from here you end up with what? Negative 2 all over what? X minus 1 all squared. Okay, so instead of doing this, you can just use what? Now this is where the trick comes in. Instead of going through the quotient rule, once you are given a quotient rule, you can convert the quotient rule into what? A product rule, and then solve it. Okay, you arrive at the same answer. So let's use the second example. Okay, let's implement that. So you have what? S squared minus what? 2 divided by, okay, so this is the second example. Okay, this is the second example. So you can notice that this is what? In a quotient form. So we have to use the quotient rule. But instead of using the quotient rule, this is where the trick comes in. Use the product rule, you arrive at the same answer. Okay, so let's convert product rule. So you have what? S squared. So when you convert this to product rule, because this is the denominator, when it comes to the numerator, it becomes what's negative. Okay, so when you move it from the denominator to what? The numerator, it becomes negative. Okay, that's why we have negative over here. That's why we have what? When you try to differentiate 1 over x, you end up with what? Negative 2 over what? This is because initially this was converted to what? Something like this. Okay, so when you differentiate this, you have negative 2 here, subtracting 1 from here, and then when you send it back to the denominator, it becomes positive 4. Okay, that's where we had this ideology from. So now let's proceed from here. Okay, so let's use the product rule over here. Okay, so for the product rule, note, keep in mind, keep one, differentiate the other. After that, you add it to what? The other, and then you differentiate the other one. Okay, so let's first keep this expression. So let's say this is u and this is v. Note that this is also a chain rule. Okay, this is also a chain rule. Okay, we'll be implementing the chain rule. Okay, so in case you remember that, you are good to go. In case you don't, just go back. It's very simple. Okay, very simple. I try to explain it as simple as possible, okay, to make it very simple. So let's proceed from there. So let's try find what? The differential. So keep this, differentiate that. So we have what? X squared minus 2. So we are keeping this and then differentiating this. So differentiating this will give us what? Negative 2. Okay, and then we are using what? Again, remember, using the chain rule, we have x plus 3. Okay, and then we have what? Negative 3 over here. After that, you differentiate what's in the bracket. Okay, that's 1. This is what? The chain rule. Let me put that into bracket so that you get to understand. This is what? Chain rule. Okay, so we just implemented the chain rule. We brought this in front of the entire expression, which is what? X plus 3. We had what? Negative 2. And then we kept what was in the bracket. And then we subtracted 1 from here. That's where we had what? Negative 1. After that, you just differentiate what's in the bracket again, and then you multiply that by the entire expression. Very simple. And then you keep this expression, okay, and then you differentiate this one. So we have what? x plus 3 exponent minus 2, and then we differentiate this expression. That's where we have what 2x, because this will go to 0. Okay, so let's do the simple expansion. So we have what okay, so note that this what you can just group this, okay, and then you can just group this. I'm just grouping it so that you get to understand. There's no need to group it, you can just do your simple expansion. So when you multiply this throughout, let's keep this out, okay, x squared minus 2, okay, and then we have what x plus 3 exponent minus 3. That's where you are doing what your simple what expansion, and then from here you have what 2x x plus 3 exponent minus 2. So you can go further to keep what expanding. Okay, since this is negative 3, we can send it to what the denominator. Okay, so we have what x plus what 3, and then when you send this to the denominator, it becomes what positive. Okay, and then plus we have 2x over here, and then this is also what negative 2, so you can make it the denominator. So you have what x plus 3 exponent what positive 2. Okay, so you can just find the LCM. So we pick the LCM to be x plus 3 or into bracket exponent 3. Okay, it's just like being given 1 over what s cube plus what maybe 2 over what s squared, and then you try picking the LCM. Most definitely you use what s cube so that it will cover s exponent squared. Okay, that's the same principle we are using over here. Once it covers, you would be just left with only 1x. Okay, that's where you divide. Okay, so let's see how this works. So from here, trying to expand this will just cancel this. We'll be left with what minus 2x squared minus 2 plus what, so this is 3, this is 2, so most definitely we will be left with what x plus 3. Okay, so we'll be left with this, and then we could just do the simple expansion. So we have from here we have what minus 2x squared plus what 4, and then from here we have what plus what 2x squared plus, okay, and then you divide that by what x plus 3 exponent 3. So from here you can further simplify. Okay, this will just cancel this, will be left with what 4 plus 6x all over what x plus 3, and then raised to the power what 3. Okay, you could see how simple this is. This is very simple. From here you are done. If you want, you can just further simplify this to give you what maybe 2 plus what 3x, okay, x plus 3 exponent 3, because you are just factorizing. Okay, so when you multiply this one out, you end up with this expression again. 2 times 2 give us this 4, and then 2 by 3 will give us 3x will give us what 6x. It's the same thing. Okay, so in case you enjoyed this video, I'll urge you to subscribe to the channel so that you don't miss out on future videos. We'll be treating higher differentials and then what implicit differentiation in the next video. Okay, so I'll see you in the next video. Kindly like the video, share, and then here, in case you have any questions, just leave them in the comment section. I'll reply to them as soon as possible. Bye bye.